Okay, what's up, guys? Welcome to a surprisingly late night session of linear algebra. The earlier lecture I recorded today had audio issues, and so I am recording it kind of late at night, the first time I've had a chance to. And yeah, so let's get into it. I'll try to keep it relatively short since this video is being posted later than usual. I won't try to take up too much of your time. It's syllabus day, so it is a short class. We will maybe very briefly touch on some of section 1.1, which luckily the audio did come through for, and I will cut that in at the end basically. But in terms of the syllabus stuff, we should be able to get through it pretty quick. It's pretty straightforward. So I'll start you out with the course Blackboard page, which you can see here on the screen. So Blackboard is going to be your one-stop shop for everything in this class since you're online students. It's the primary platform we're going to use for most of this stuff. Hopefully you have already seen an announcement here. I'll actually jump into the student preview mode so it looks the same as what you'll see. Hopefully you've already seen that there was an announcement today about the video coming in a little bit late. So if you didn't get that, hey, really great chance for you to test your announcement settings. If you didn't get the announcement, go in Blackboard, change your settings, make it so you get notifications on that sort of stuff. Basically, the gist of it is that while this might look kind of complicated to navigate, it actually is not too bad. Let's see. Oh, my video is frozen out there. That's weird. Anyways, so all you really need to ever go to is the content section, the announcement section, and the gradebook section. That is everything that we'll be using pretty much. Announcements, you should get all these by email. You should get nice notifications. It's how I'll communicate and tell you stuff about what's going on in class. I'll give you updates that lecture videos have been posted, all that kind of good stuff. The gradebook will have your grades in it, and the content area is everything else. So we'll go through all that. We'll talk about the syllabus. We'll talk about everything. And we'll get you set up. Hopefully this should be as similar to an in-person class as it can be, except for perhaps this video. That is, what I'm going to do throughout the course of the semester is I'm going to record an in-person session of class and try to direct it simultaneously both towards the in-person students and the online students, instead of, giving lectures to empty rooms by myself, which is always less engaging, and I think lacks some of the natural kind of flow that goes on in an in-person setting and makes the class feel not as fun for you guys. So I will generally post those right after class. I may live stream them to give you a synchronous option if you want, but you can watch the videos anytime. I will always make sure that there is some way to do that, and it can be fully asynchronous as advertised. But yeah, so the gist of it, we will go through the syllabus together, which you can access via the course materials, and we'll get the gist of it, the idea of what's going on. So if we go to the course materials page, you may have noticed when I clicked it there, it took me out of Blackboard. The reason for this is relatively simple. If you've taken a class here at UND before, you probably will notice that this Blackboard page looks slightly different than Blackboard pages you may have seen before. That is, this Blackboard page is in Blackboard Ultra, which is, in my opinion, a slightly inferior platform to the old Blackboard. It is fine. It just makes it difficult to navigate through large numbers of files. That is, everything is arrayed in terms of these drop downs. And so if you want to have like multiple layers of them or lots of files, it just means that everyone has to scroll a ton. And that leads to some kind of organizational issues. So for the course materials, I just made them in some Google Drive folders, put it on my personal website, and that way you can access everything at once without having to scroll through page after page of links and try to pick the right one out. It's all here, and I'll go through everything together as we get to that part. But the first things first, we'll go to the syllabus section, and we'll click on Syllabus Online Students to look at our syllabus. So we have our syllabus in front of us now, and if you want to pause the video, take a moment to navigate towards it yourself, that's fine too, or we can read along together. Here's the gist of it. You're in Math 330, Proof, Set Theory, and Logic. Hopefully this is no surprise to you. I am Bryce Christopherson. I will be your teacher this semester. I've been teaching for, I guess about 10 years now. Before I taught at UND, I did a brief stint in the defense world, and then before that, I taught at the University of Wyoming. I love all things math, and I look forward to teaching it. This will be a fun class. This will be a great, hopefully gentle introduction to proofwriting, which is the best part of math in my opinion, the most fun part of it. Um, it is very different from the computational aspects of the math classes you may have previously taken. If you've written some proofs already, wonderful. If you haven't, totally fine. We'll get you into it in gradual steps, since it is kind of a huge change of pace in terms of how math classes operate. That is, we won't just be like, calculating some very specific thing, something like that. Instead, we will be proving theorems, the bread and butter of mathematics. So it'll be fun. Class is on Monday, Wednesday, and Friday. At least that's when I post videos. You can watch the videos whenever you like. It's up to you. The location is online, right? I will show you how to get to the videos later on. If you're watching this, it means you've at least been able to click a link in one of the announcements, but I'll show you where they're all stored for later use if you want. I also have a nice hyperlink clickable email address right there. You can shoot me emails if you need to talk to me about anything. If for whatever reason you do want to come into my office, I have my office there. But if you are not on campus, then that's probably irrelevant to you. You probably just want to do office hours by appointment on Zoom. That is, I found doing like the Zoom office hours is a, I don't know, it doesn't function as well as just doing real life office hours. Like having people just stop into a Zoom room, as soon as like the second person comes in, it just becomes kind of a mess in Zoom, while it feels less you know, like everyone's talking over each other in a Zoom meeting. In real life, when people, can interact multiple together without as much a technical challenge. So we'll do Zoom by appointment. Shoot me an email. I am very flexible. I can work with you. Just let me know what you got, and I'm happy to meet. So yeah, let's get into it. Syllabus, most of this stuff, pretty normal. If you're in this class, you've taken classes before, you know about how syllabi work. I'll skip over a lot of the basic stuff. This syllabus, like what is this about? We all know what syllabi are. Prereqs, if you're in the class right now, you satisfy the prereqs. The textbook is the first piece of substantial information. We're going to use an in-house one, Elementary Set Theory by one of the members of our department, Richard Millspot. It's a great little book, a wonderful introduction to set theory, and it's free. There is a PDF copy of this book available free of charge under the textbook section right here in the course materials page, which you can always get to by clicking that first link on Blackboard. And if you do, it'll pop up a PDF copy of the textbook, yours for free. What a wonderful thing. All 111 pages of it. If you want to print it out, you sure can, but you definitely don't need to. Fun. There you go. We also have some guided lecture notes, which I will use very frequently and I think are super helpful. I encourage you to use these. Print them out if you want. They are pretty helpful, I would say. I have blank versions of them, and I also have keys posted for them. So in the in the blank versions, here's the blank version. We have things like, the definitions are already in there. So you don't have to scramble trying to write down a definition or spend a lot of the lecture watching me slowly write a definition. Instead, you can just have it right there, and you can focus on understanding what it is saying and what it means instead of trying to write it down quickly enough to keep up with the class. However, I have left blank spaces for the examples. That is, when you actually are practicing the skill or understanding the thing that's being defined. I've given you room to do that. And I also have a nice key with solutions for everything. And I have tried to do the solutions in the case either I or I've taken chunks from the textbook for most of this. but I've tried to put them, all nicely formatted and easy to read while also giving you enough space to put things here. So this is basically, if you, in a nutshell, the lecture note packets are the textbook. I've cut apart the textbook into little chunks, and I've pulled proofs and examples apart, left spaces for all that, and yeah, it'll guide you through everything. So if you want to use that, wonderful. I think it'll help you, keep pace with the lecture and kind of give some sort of common structure to how we're doing things. But if you prefer to write them on your own, you don't need it. You can throw the note packet away if you don't want it. It is only to make things easier for you. If you find it harder to use, don't use it. Write notes the old-fashioned way. Do whatever you want. It's just there to help. Um, Cool, wonderful. So textbook, free online, note packets to accompany it, also free online, wonderful, great. You can also have a calculator if you want. You don't really need it. Like I said, this is not primarily computationally focused here, but more so on proofwriting, so you won't need the calculator so much. But if it does make you feel more comfortable, use it, whatever, that's fine. Blackboard, we've already talked about Blackboard a little bit. Let's talk about it a bit more. This is the primary platform that we'll be using for everything in this class. Like I said, we've already talked about the tabs that you need. Now let's go through the rest of the links on this first page, this content page, which is real the meat and potatoes of what's on Blackboard. So the first thing is the course materials. We already went there. This takes you to this page, which has all of the files you need, the lecture notes, both blank and complete. The homework assignments, we'll get to that when we talk about homework. The syllabus, we've already looked at that. The textbook, we already saw it. And then this big red YouTube button right here will take you to the lecture video playlist on YouTube where all of the videos will be posted. It is currently blank because I have not yet posted this first one, but by the time you look at it, it will have a video in it. We use YouTube because everyone, knows how to use YouTube. It doesn't have any sort of mess with it like some sort of internally hosted university video thing or something like that. And YouTube does lots of great stuff, generates captions really easily that are pretty good, stuff like that. Yeah, so great. That's where you can get there. You can also click the second link on course content to go to the exact same playlist. So you can access it in multiple different ways. Lots of redundancy set up here. The next folder says exams. If you click on it, you will see nothing. That is because none of the exams can be accessed yet since they are not out yet. It is not an exam day. We'll talk about exams soon. The thing after that is the homework. We'll talk about homework more soon, and we'll come back to this. Finally, there's the syllabus and student help and resources. We've already looked at the syllabus. Student help and resources, that is just a collection of like the sort of stock links that are in every Blackboard page. Some of the UND resources that may be of assistance to you. If you want to ignore that tab, that's totally fine. It is just additional stuff that can help you out. So the syllabus, great. We're back to it. Blackboard, pretty much went through everything there. If you have any issues doing stuff with Blackboard, I've got a bunch of links here to tech support and all that. Grades, the thing people probably care about most next. So grading is going to be pretty straightforward. There are 3 exams and a homework, or some homework. All of it is worth the same. That is, the homework is 25% and each exam is 25%. Pretty straightforward. The exams are basically over between 2 and 3 chapters. 2 chapters on the first exam, 3 chapters on every exam thereafter. And the homework will be 1 per chapter, pretty much. We'll go through that when we look at the schedule in a moment. So the grading scale with the letter grade, 90 to 100 is an A, 80 to 90 is a B, so on. Usual kind of 10 percentage point blocks. That's like the guaranteed grading scale. To preempt all of the inevitable questions that pour in at the end of the semester, yes, I will round you up if you are very close, right? I won't make you get a B instead of an A if you have an 89.5%. I will round you up. So the grading scale may actually be more generous than this. Like usually I look at it and I see like, oh, do I have a couple people really, really close to the cusp? I'll move it slightly behind that. But it will certainly be no harsher than this. So there you go. Incompletes. Please talk to me if some situation comes up that would lead you to needing an incomplete. Don't just give up on the class and fail for no reason. I am fine working with you to accommodate stuff like this. I've done it before. I know that things happen in people's lives, and suddenly something comes up and you can't do something for a few weeks, and then you feel hopelessly behind and like you have to quit. You can just take an incomplete. It's not a big deal. I would prefer not to do too many of them. A lot of the times when people do incompletes, they end up still not finishing it. So don't hopefully like rely on this. But if you end up needing it legitimately, I am happy to work with you. Um, Exams, all the exams, including the final, all of these guys will be administered online. After all, this is a fully online course, so you can do that online if you want. There's no trouble there. On the exams, you'll get, problems pretty similar to homeworks. You'll complete them during a fixed time period on a specified date, unless you have some particular good reason to take it on a different day. However, you don't have to take it at a fixed time. So that is, you can do it at whatever time is most convenient to you, but there is still an exam day, just not an exam time on that day, if that makes sense. Cool. If for whatever reason you have to miss an exam, talk to me in advance so we can set things up. I know that some stuff does happen last minute, but to whatever extent you can, please try to give me notice or warning. There will be makeup exams if you need them, but the main thing that's next is homework. So 7 written homework assignments will come out during the course of the semester. Everything except the last chapter, every chapter except the last chapter, chapter 8, has a homework assignment associated to it. Each assignment only has one deadline with it, and this is kind of a controversial, I guess, grading policy that I'm going to use here, but I'll explain why I do it. What I'm going to do is I'm going to be kind of a stickler for due dates with homework as much as I can, because what I'm going to be grading you on is primarily completion. And I know that sounds kind of hokey, but what I've found in some of these proof-based classes is that it can be a little bit more labor intensive for someone to see what they've done wrong if I just straight up like give you a numerical score, and people will just not do it, especially if they really need to, right? If you get a super low score and you go like, wow, my proofs must have been entirely wrong. It is more work to go back through and figure out what went wrong than it is, for instance, to go back through and figure out what went wrong on like a calculus exam. You have to not only know, like understand what the right proof is, which can be, or a correct proof is, which can be more difficult. You also have to understand what's incorrect about the proof that you submitted. And this can also be a lot harder to do than figure out what went wrong on a routine computational problem you might do in a previous math class. So what usually ends up happening is if someone does poorly on an assignment and I just score it kind of, in this classic way, if you get a lot wrong, you end up not looking back at it because you're like, well, I don't get anything from doing that. I better focus on my next homework. And it will take too long for me to look back at this assignment. So just move on. And I'll write a lot of comments, and the comments that people most need to read, they tend not to read. So I think it is much better for a class like this to instead just effectively periodically check that you are practicing things, and then, as mean or kind of perhaps lazy as you want to say this is, force you to get practice at assessing whether or not an argument that you present is actually a good argument. That is, actually reading proofs and determining whether or not they are correct. It is a difficult skill, probably one of the most important skills that you can get here. We want you to be able to not only produce proofs that are correct, but to ascertain whether or not a proof presented to you is correct, since you'll have to do that with your own proofs. So I will only check on the due date for your homework, whether or not you have made a good faith effort to do the assignment. If you have, full points, all good. Then, right afterwards, I will release a very detailed answer key that you can check your assignment against. You can look at the proofs, you can look at what you wrote, you can say, did this make sense? Like, if you feel very strong on a proof, okay, skip over it, don't do it, whatever. But if there are ones where you're like, I'm not sure if I did that right, you can read a correct proof, you can read your proof, and you can go, okay, Is this the same? Is this different but still correct? Is this different but actually incorrect in a kind of important way? So on, right? You get a lot of good practice there. I am, of course, happy to score anything that you submit in the classical way if you would prefer. That is, I will give you super detailed feedback on any proofs you submit. All you have to do is ask, but you have to look at them first and get some practice telling whether or not the proofs you write are good. It will help you, as annoying as it is to do. So, I'll be a stickler for deadlines, but I will not be a stickler for little tiny mistakes you might make. Instead, I will just basically be checking that you actually are practicing. Extra credit will occur at a couple points in the semester, usually on exams, stuff like that, maybe a few homework problems, something. It won't change your final score all that much. But hey, it's not a bad thing to do, right? It's fun. Attendance, I'm not keeping track of attendance. I'm not like monitoring who watches what video. If you do not watch the videos and you start to fall behind, then I will definitely be like, well, the first thing you should do is, watch the videos. But I'm not directly checking that or grading you on that. So yeah. But yeah, if you do start to fall behind, the best thing you can do is to find some way to get help. One of the easiest ways is to send me an email. Send me emails frequently about any questions you have. I will provide long, detailed, nice responses, I promise, in a relatively speedy amount of time. I am always happy to answer any questions you have. I can do Zoom meetings with you if you like. We can do stuff like that. You can also meet with your peers in this class, do study groups, do little Zoom study groups, work together. That is not bad. That is not cheating. If I see that you and another person have, come up with a relatively similar proof, I'll probably say like, oh, they worked on it together. I won't be like, hey. And the reason for this is because, well, 75% of the class is exam based, and you will not be able to do that on exams. So if you rely too heavily on someone else, you can't pass the class with a 25%, right? So if you don't know how to do any of it, that's gonna hit you on 75% of your grade. So study groups are good. Don't use it to avoid learning. Use it to help your learning, because otherwise you're just gonna hurt yourself. Um, and that's kind of the deal with academic integrity overall. It is hard for me to tell in this day and age whether or not people are cheating on some things, right? It's easy to feed stuff to ChatGPT, look stuff up on Stack Exchange, things like that. It can be hard to, catch. And honestly, I don't want to play detective. You won't be able to do it on exams, or if you somehow are, you do so at your own risk, I guess. We'll use honor lock for exams, which I will talk about more closer to the exams. But basically, it's one of those pretty straightforward take the exam with your webcam on type things, and it like monitors that you're not looking stuff up on the internet, at least on the computer that you're doing it on. For the most part, I think this catches pretty much all cheating, and people can come up with crazy, James Bond style contraptions to somehow get around this. I've heard, but overall, I think it's at least as good as proctoring in person, right? I don't want to catch anyone cheating. If you do, there's a fair chance you will get caught, and then I have to do a ton of paperwork, and you have to, sit on like academic affairs hearings or something. I don't know, right? It creates a ton of work for all of us. Please don't waste a bunch of my time. Please don't waste a bunch of your time. Just be honest. Usual stuff. I don't know why every professor has to give a speech about cheating being bad. We all know this at this point. Yeah. But next thing up is disability statement. If you need accommodations for this class, that's totally fine. Talk to Disability Services Center at the university here. They will help assist you, and I am glad to work with any accommodations people need. And then finally, course evaluations. Near the end of the semester, you'll get the old self-eye, whatever, evaluation thing. Please fill it out, especially with smaller classes like this. If not enough people fill it out, then it doesn't actually release the responses to me since they're not like sufficiently anonymized, right? So fill them out, please. Even if you have nothing to say, just fill them out so I can read stuff from the people who do have something to say. Yeah. So next up in the syllabus is this big old rubric right here. We will talk a lot about, good written mathematics in this class. For the most part, this isn't something you have to study or anything like that. It's just kind of something for me to point to when we're talking about how things are graded. So that way, if someone says, hey, I think I should have got a very good score instead of this score, I can say, well, look, you had little to no correct usage of terminology and notation. Then that would be this. So, it's more of like a kind of, there should be nothing surprising in here, I guess. Is your work well organized? Is it correct? Is it clear? All the usual stuff. We'll talk a lot more about the subtleties and nuance of good mathematical writing as the course progresses, but that's kind of a nice handy cheat sheet. And finally, the course schedule. This shows what we do every single day of the semester. You got the day, top line tells you what we go over. And then if you go down a little further, you'll start to see some of these bolded ones on the bottom line for each cell. These are the due dates. So homework 1 is due on September 19th, homework 2 on October 1st, and then there's exam 1 on chapters 1 and 2 on October 3rd. So if you ever miss class or you wonder what's coming up, what we're doing next, you can consult this, everything. We will follow this pretty much right to the letter for the most part. And yeah, there you go. It tells you what we're going to do and when we're going to do it and when we have class and when we don't. The structure of it is basically that there is a homework about 1 week, give or take a couple days because of holidays and stuff like that, after we finish a chapter. So notice we'll finish chapter 1 on September 12th. The homework for chapter 1 will be due on September 19th, exactly 7 days later. This is pretty much the case for everything for the most part. See, homework 2 is due a week after we finish chapter 2, all that. Pretty straightforward. There's a review day before every exam. The structure of the class is basically to have us, standardize the pacing as possible. No weird jump scares there. Just, slow and steady wins the race, right? So that's pretty much the syllabus. It tells you everything you need to know, and hopefully gets you ready for everything in this class. I believe that brings us to the last items here, which are the homeworks. The exams we'll talk about closer to the exam. It will be online. I'll show you what it looks like basically before the exam. But the homeworks are the next thing. So on Blackboard, there's a item that says homework. This is where you submit your homework. All you have to do is click, the view instructions for your submission. And you can either, you could type your thing here if you wanted to. That'd be a pretty wild thing to do, but you could. I imagine most of you will just include attachments or images, probably attachments. Just take pictures or scan your assignment if you want to do it by hand. Everyone's phone's good enough that it's basically a scanner anyway. Don't give me like horrible grainy photos from across the room, right? Try to take clear, easily readable pictures of each page of what you write, and that's fine. You can also scan things. You can type things up in Word, LaTeX, whatever the heck you want. Totally fine. It doesn't really matter as long as I can read what you're submitting. I'm good with it. Yeah, so you just click attachment, you attach it, and then you submit. Easy enough. Bada boom. But to actually find the assignments, they are all already posted in the homework section of the course materials, which remember, you get to by clicking the first link on Blackboard. So you go there, all the homework assignments are already posted, or at least I have constructed homeworks for each piece, which basically are exercises just from the textbook. Modified perhaps slightly. These will have the corresponding answer keys go live immediately after each due date. But yeah, they're all about, in the 10-ish problem range. You have about a week for each one of them. Some of them have more parts than others, but none of them are particularly I don't want to say none of them are particularly difficult. Some of them can be difficult, but none of them are difficult in terms of their length. That is, none of them are just like extremely long, and that's what's hard to do with them. They're all, I hope, of a reasonable length. Some of the problems may be harder than others, but none of them are brutally long. They're all relatively pithy. And yeah, you can find them all right there. Now, caveat to those of you who like to work ahead, some of the later homeworks I may cut off some problems from. That is, I will certainly not add a bunch of new problems to them, but depending on how fast we're going through things in the course, maybe we have to cover some section in a little bit less depth, and I cut off a few problems from an assignment. That could happen. It's fine that it does. This is, some minor adjustments and stuff for pacing as we go through the class. I may pull off some problems from later homeworks, and so if you're working ahead, you may end up getting more practice than you necessarily absolutely need to, but shucks, I guess you'll be really good at this then. If you do the homeworks ahead of time, it's certainly, I will never penalize you for it. I may just, actually make it that you've practiced more, right? So just a little warning, because sometimes people get mad about that when they go like, oh, I spent forever on that problem. It was so hard when I did it 2 weeks before it was, 2 months before it was due, and then you removed it. And oftentimes people are kind of answering the thing they're saying as they say it when they go like, well, I took forever on that really hard problem. Why did you take it off? The answer is probably because it was too hard. Something like that. So, yeah, just fair warning on that. But yeah, that's pretty much the deal. All of the rest of the lectures, except for this one, will not just be me talking over a web page. They will all be nice videos of the classroom. I have a ceiling mounted camera and, the lapel microphone and everything. Hopefully they'll be engaging. I will have to repeat the questions the students in class might ask. One, because I don't want to violate anyone's privacy by having people's voices be audible and all that. And two, because I don't have, everyone equipped with, hidden microphones. But other than that, it should, be a pretty straightforward thing. There might be a couple of weird little kind of, technical kind of quirks from it. But other than that, hopefully it'll give you the sense of being in a regular classroom and we can have the same kind of engaging dynamic. So yeah, without further ado, let me cut over to a tiny bit of introduction to section 1.1 that I believe made it through with good audio from earlier today. And yeah, we'll talk to you next time. Okay, so if you open up your note packets to section 1.1, you'll see that it's very, very short. Why? Because it's the first day. Okay, so what are we going to do first in proof, set theory, and logic? Well, the first thing we're going to do is we're going to talk about, that is kind of loud. Is it? Getting some feedback. Oh, well, we'll figure it out. There may be some slight technical hiccups at first, but it'll all come together. So first thing first, here we are in chapter 1. And we are in section 1.1, propositions. Propositions. Okay, so here's the definition. You see this all in your packet. A proposition is a statement that is either true or false, but not both. Okay, pretty straightforward. I mean, I guess this is kind of informal in some ways. You might say like, what? Okay, so a statement about what? How can you tell if it's true or false? Well, I'll talk about all that stuff soon, but just at the very beginning, we're going to start to talk about propositional logic. So logic involving statements that are either true or false. What those statements are about, how we determine if they're true or false, we'll move to that in a little bit. But for the beginning, just suppose we have some way to ascertain whether or not a statement is true or false, and we're making statements about some sort of well-defined object. Okay. How can we tell if things are propositions or not? Well, let's do a few examples and kind of get a sense of what propositions are. So here's the example. Determine whether each of the following is a proposition. This marker is extremely squeaky, so I will have to find a new one for next time, because I don't like that at all. 2 plus 2 equals 4. Is this a proposition? Yes, yes, absolutely. Yes. Okay, what about 7 minus 3 equals 12? It is a proposition. It is a false statement, but it is certainly a proposition because it has unambiguously a true or a false value, right? Okay, sweet. Okay, I think everyone's catching on to this. It will snow in Grand Forks on March 17th, 2525. Will it?
True or false? True or false? It could be true or false, but it's unknown. So.
I see. Okay. So this statement, you're saying, I don't know whether it's true or false. Is it a proposition? Okay, this is a good distinction. A proposition is a statement that is either true or false. It is not a statement that you necessarily know whether it is true or false. But it has to be one or the other, right? So it is a proposition. Yes. It either will snow in Grand Forks on March 17th, 2525, or it won't. There is no other possibility. Yes, it is a proposition. It is one we just do not know the truth value of. Okay, now here I'm testing my very fancy camera panning, which you guys can't see, but I have it configured so the cameras pan between the boards. Ooh, fun. All right, here, let's try another one. I grabbed the wrong packet. All right. Go clean your room. No, that's a command. It's not something that can be true or false. It's just a statement of them telling you to do something. No, not a proposition. Okay, what about, is it raining? It's a question. While you can answer this with either yes or no, it might seem like a proposition in that regard. It is not itself a proposition, it's a question. Okay, you'd be surprised how often people get confused on propositions and questions, and you may find yourself make the same mistake at various points. So no, this is a question. It is not a proposition. All right, what about this one? This one's a hard one. This sentence is false.
It's not a proposition. It's both true and false.
Yeah, it doesn't have an unambiguous truth value. That is, if the statement is true, well, wait, it can't, if the statement is true, well, then that would mean that it's false. But if it's false, then that would mean that it's true. Oh, okay. It's not a proposition. And in fact, this is the kind of thing we have to be very careful about in set theory, which we'll talk about very soon, is that self-referential statements can cause a whole lot of problems. So this is not a proposition. It has no clear truth value, right? We'll see this if you've ever seen some of the paradoxes of naive set theory, then you probably recognize what this is an example of. But we'll see this very soon in a more formal context, how this kind of thing can cause problems. Self-referential statements can be tricky. Now here's one that might throw you for a loop. What about this? X plus 3 is 12. What do you think?
Not a proposition, because next you make that statement a true or false.
If you substitute a value for x, then it could be a true or false statement, right? But without substituting a value for x, this is just I don't know, a string of characters or something like that, right? Now, I guess I should say that perhaps this is somewhat dependent. Equations involving variables, you should not just immediately jump to saying like, hey, something involving variables is automatically not a proposition. For instance, you could say something like, here's an additional example. This is, to be clear, not a proposition because you can't say whether that's true or false without specifying more information. However, there can be statements involving variables that are propositions. Here's an example of one. Yeah? You'd agree with that, right? Oh, okay. It involves variables, yet it is indeed a proposition. Why? Because it is unambiguously true in this case, right? Okay. Wait a second. Can't I do something like this here, right? Like, x plus 3 minus 12 equals 0 or something, The point is that here, this is a statement about polynomials, right? That is, I guess what I'm saying is that statements involving variables are potentially trickier because you have to be clear about what you're talking about, right? If you're talking about, something in like the same sense as what we were saying over here, where you say you have to specify more information about x to know whether or not this is true, then this would be a statement that is also not a proposition because you have to specify more information about x to say whether it's true. It doesn't matter that you have to specify, any old x or something, right? It'll be true for any old x, okay. The thing that would be a true statement would be for all x, this. However, if we're reasoning about polynomials, then this is just a statement exactly like 7 minus 3 equals 12. It's a statement about multiplication involving polynomials. While if we're talking about functions, this is not a proposition in of itself, right? Okay, so maybe that gets a little bit more confusing. We'll do more examples like this sort of thing later. You'll see what I mean as we go through. But the whole point is that variables can be tricky to deal with. This is not to say that you're just going to have to kind of like wing it heuristically throughout, but hopefully this motivates some of what we'll do in the next few classes when we begin to talk about quantifiers. That is, we have to talk about, hey, if I'm making a statement involving some variables and stuff like that, or if I'm making a statement where I say, like, for instance, it is always raining, I should be talking about where is it always raining, or something like that. If I'm making a statement about numbers, then I should talk about what numbers am I describing, right? And so on. So statements involving variables, it can be more difficult to ascertain whether they or not they are propositions without knowing something about the domain of discourse and what we're actually talking about. That is, we'll have to be a lot more specific than just how we treat words in, regular old English. So hopefully this is a good ending place to kind of motivate what we're going to do next time, where we will be a lot more specific and we will start about, well, I guess we'll get to that next time. So I'll see you later. If you have any questions, let me know. And yeah, have a great day.
Nice meeting you. Yeah, me too.